Hello. Today we're going to talk about estimation, and in particular something called large effort estimation. Imagine you've got something really big that you need to estimate because the bosses want to know how long it's going to take to deliver and maybe how much it might cost to deliver a function, a feature, some benefit, some outcome that the customer desires. Now, we're going to assume that in this video you understand how to estimate using some agile techniques such as affinity estimation, otherwise known as t-shirt sizing, which is a twist on what we're going to use today in this video, or you've got some familiarity with planning poker or points-based estimation, number of different names for this. This isn't a video to debate the virtues of estimation using points of some description. We'll talk about time versus point in another video. This video's all about how do you get a budget for something that isn't pre-planned and predetermined and has a laundry list of requirements that you can add up and give an exact, precise price for it, because we know that's nonsense anyway. So what we're going to do is we're going to look at how do you estimate with some level of accuracy, and the technique I'm going to show you has been proven over more than 4 years of consistent use both in and out of Toyota to be 90% accurate. So we've got a maximum deviation of plus or minus 5% from our estimated baseline, which is pretty powerful. Of course, during the initiative, project, the product delivery, whatever you want to call it, you will continuously update those estimates. So let's go ahead and have a look at this technique and see whether it's useful to you. Welcome to Large Effort Estimation, based on an original idea by Dave Slayton. Dave and I have known each other for many years, and he developed this technique originally when he was working in Christchurch, New Zealand for Tate Communications while he was a Scrum Master. He taught this technique to me. We first deployed it in Toyota motor manufacturing in Kentucky, and it was so successful that I started to deploy it across the whole of the Toyota landscape and teach it to all the people who worked with me. And of course, we taught it to companies outside of Toyota when they consulted with us when we were running the Agile training capability outside of Toyota. So let's say you've got a really big product that you need to estimate, you need a budget for planning purposes, and the CFO wants to know how much this thing is going to cost, and the CIO and the CEO want to know when it's going to be delivered. Let's first look at product backlog item composition, PBI composition. So if we've got a really big product, then typically this will break down into smaller component parts, key themes, key features. The naming conventions aren't really important, but if you're familiar with a technique called story mapping by Jeff Patton, this is the sort of basic technique. If you're not familiar with that technique, I'll do a session on that in the future, or you can Google Jeff Patton and story mapping. But assume we break down the really big product into 3 key themes, then we can break those key themes down into even smaller pieces. You might call those epics. It doesn't really matter what you call them, but it's the concept here is the decomposition of the backlog. We break things down gradually into smaller and smaller pieces until we're at the lowest level, which is typically a task. Now, the first thing you want to do is to ask your Scrum Master or whoever is the custodian of the information of projects and initiatives and product delivery that you've done in the past. The first question you ask yourself is, have we done anything like this before? So if we've got an initiative or a feature delivery which looks very much like something we've done before, use that estimate from the actuals of the previous work, because that's probably the best you're going to have. So there's another way of doing this. Why don't we just write out every single user story or every single backlog item we could possibly think of until the end of time, because that's exactly what we want to do. Isn't that correct? Because that would give us our detailed estimate. Of course, that's absolute nonsense. We might as well write a requirements document, and the whole concept of emerging requirements and emergent learning and iterative delivery sort of goes away if we're going to write everything out at the beginning. And even if we do write everything out at the beginning, we're going to end up throwing a bunch of that away if we are then working in an iterative way and getting customer feedback as we build the product, because a lot of those early assumptions are not going to be valid anyway. So what we need to do is to start breaking down the work. Now imagine we've got 3 key themes. We've taken our really big idea and we've broken it into 3 key themes or 3 key features or blocks of work. Again, don't worry about the naming conventions. And let's say then we've broken down those into some smaller pieces, and for sake of argument, I've just called them epics. An epic is really just a big user story. Now the first thing we're going to want to do before we start looking at how to do this estimation is get together the team of experts who are going to help create the estimate. This is typically the team who are going to do the work. Unfortunately, if you want to arrive at a reasonable estimate, you are going to need to have people who are familiar with the work that you're going to be doing and have some subject matter expertise in this. And typically that will be the team or even a collection of teams who are going to work on this large initiative. Once you've got those, let's go ahead and break down our really big product, really big initiative into 3 key themes. Again, don't worry about the name, key theme, the naming conventions aren't important. Whatever the next level down is in your context or world of understanding. Really big thing, what's the next level of decomposition? In this example, we've broken down that big thing into 3 key themes. And using the traditional Fibonacci scale, I'm just going to go ahead and estimate the smallest item. So the team have looked at the 3 big chunks and said, hey Nigel, this one is the smallest item. And I'm going to give it a 3. It doesn't really matter what number I give it, but in this example, I'm going to give it a 3. That's the number I've chosen for a reasonably small item in the estimation scale that we're familiar with. Now what I'm going to do is estimate those other 2 key themes, either side of that one. And the one I chose in the middle was just for visualization purposes, not for any specific reason. So this one in the middle we think is the smallest. We've given it a 3. We then decided to estimate the one on the left as 13 points and the one on the right as 8 points. So the one on the right is 2 times bigger than the one in the middle, and the one on the left is 3 times bigger if we're using the Fibonacci scale, 3, 5, 8, 13, etc. So now we've got a relative sizing between the piece in the middle and the 2 pieces either side. So they are relatively sized. The piece on the left we now know is 3 times larger than the piece in the middle. The piece on the right is 2 times larger than the piece in the middle. So far so good. Okay, so now what we're going to do is we're going to take that key theme on the right, that 8-point key theme, and the reason I'm choosing that one, it just makes the presentation easier graphically on the screen. There's no reason I chose that over the 3 or the 13, other than it just makes presenting these visuals easier. So we've taken this size 8 key theme and we're going to break that down. And in this case, I broke it down into 3 chunks. Again, the size of the screen limits how many blocks I can put. So in this case, there's just 3 blocks. They may be more in your real-world context. So we've broken down this chunk, which is 8 points big at the key theme level, into smaller chunks, which we're calling epics. And I've gone ahead and estimated those with the team. And the team have decided that the blocks, or these epics, are sized 5 points, 13 points, and 6 points. And before you all go, 6 points isn't a Fibonacci number. It doesn't matter. They've taken the average of their estimates while they were estimating together, and within the rounds of estimation they were doing, they decided to take the average of the numbers that were being voted by the team, and that in this case happened to be a 6. And it also is going to make my mathematics a little bit easier as we progress through this example. So what we've now done, we've now been able to size relative to each other the decomposition of the size 8 key theme. And we've decided that those 3 epics in total add up to 24 points. So we now know at the epic level, 24 points of epics equals an 8-point size key theme. So now what we're going to do is we're going to take one of those epics. And in this case, again, just for the ease of presentation, I'm going to take the size 5 or the 5-point epic that was part of the decomposition of the key theme, which was 8 points at the theme level. And what we're going to do is we're going to break down the size 5 epic, or the 5-point epic, into smaller units, and for the sake of argument, I'm going to call those user stories, and we're going to estimate those user stories, which are typically the smallest amount that you will estimate. We don't estimate tasks either in time or points. That's a conversation for a different video, but in this instance we're going to only estimate to the user story level, which are the smallest level of decomposition the team are going to use when planning their sprints to deliver features, functions and capabilities in the product that they're delivering. And for ease of mathematics, the team have estimated these user stories, there's 7 user stories, and they total 40 points. Again, the points are relative at the level of decomposition. So when we estimated the key themes, those points were only relative to each other at that level of decomposition. Again, at the epic level, the 5, 13 and 6 are only relative to each other at that level of decomposition. They're not relative to the points we've used to estimate the stories, which are only relative at that story level. So now we have 40 points of stories, which collectively equals 5 points of an epic, and collectively those epics equal 24 points for that size 8 theme. You may be able to see where we're heading now. So let's look at the math. It's not my strong point, so I'll do my best. We now know that a size 8 key theme broke down into several pieces. One of those pieces was 5 points at the epic level of decomposition, and we further decompose that down to 40 points of user story points at the user story level. So we can now say a 5-point epic equals 40 story points. Or if you prefer in simple terms, a size 5 blue block equals 40 points of yellow blocks. So we can therefore say that a size 1 block is equal to 8 points of yellow blocks. The ratio is 5 over 40 equals 1 over 8. That's as far as the maths are going to go here, but I think that's reasonably obvious. So let's start extrapolating these numbers now, so that we can actually see how big our really big initiative is. We know from our earlier calculation that a size 8 key theme equals 24 points at the epic level. We can then do a ratio and say, well, if 8 equals 24, 1 equals 3. So a 1-point key theme would be 3 points at the epic level of decomposition. We also know that a 1-point epic, because of our earlier math with the story points, equals 8 story points. Now, if we start to extrapolate those numbers, we know that that size 8 key theme is 24 points at the epic level. We know a 1-point epic equals 8 points, therefore 24 epic points multiplied by 8 story points, 24 times 8, equals 192 story points. So we now know our size 8 key theme, our 8-point key theme, is equivalent of 192 story points. So now we can go ahead and estimate the rest of the large initiative. We know that this 8-point epic equals 192 story points, so therefore we can say that a size 1 epic equals 24 story points, because if 8 is 192, divide 192 by 8, therefore 1 equals 24 story points. Therefore, the total across of all the key themes, the 13-point key theme plus 3-point key theme plus the 8-point key theme we've been working with, equals 24 points at the key theme level. Therefore, 24 times 24, ironically, equals 576 points. So we now know our really big product is equal to 24 points of key theme, which equals 576 points at the story point level. So we used to think it would be more accurate if we took more of those key themes and broke more of the backlog down to get additional data points to extrapolate for the overall size of the initiative. So if we had, I don't know, 20 key themes and we broke 5 of them down, and we broke those down into epics and then broke one of those epics down into user stories, then that would make us more accurate. It didn't. It made us no more accurate at all. And just breaking down one key theme into epics, taking one epic, breaking that down into user stories, and again, it doesn't matter whether you call them themes or epics, features, functions, capabilities, whatever works in your context. But we found that just taking one chunk, breaking it into smaller pieces, one chunk of that, breaking that all the way down to user stories, and then being able to extrapolate that to size everything else, was actually around 90% accurate. We couldn't get it to be any worse than that. We thought, well, if it was 70% accurate, we'd be happy. But in the end, it turned out we were incredibly accurate, and this has been used for years to size all sorts of initiatives up front for budgetary purposes. So we get a rough idea of when we can deliver, and we get a reasonably good estimate of how much that's going to cost. So let's look at how we can use this data in helping us trend our delivery. So let's take our really big initiative. We calculated that it's 576 story points. We know our current team velocity this sprint is 45 points. So if we divide 576 by 45, it's roughly 13 sprints. Fantastic. Except we don't use all our velocity, 100% of it, on our sprints. I wish we did, but we simply don't. We may have some improvement activity. We tend to call that Kaizen. You may be reducing some technical debt, so you've got some user stories or backlog items to reduce your technical debt. You may be getting interrupted for urgent requirements. The system is down, a tech support inquiry. We call that interrupt work or interrupt profile. You may have some emerging work, some work you didn't even think was there, and you suddenly got some additional work you have to do, and maybe some other stuff that just happens to crop up. Now, I've normalized these numbers. They're rounded just to give it an easier math, but roughly that's 75% of our known velocity is being able to be applied to new value, but unfortunately, that only leaves us 34 points, and 25% of that velocity is being consumed by some of these other potential activities. And this is reality. This is what we call adjusted velocity. So let's adjust the release plan. We've now got our 576 points, our adjusted velocity, our average, what we're calculating over several sprints. We've adjusted that to 34 points. And now we look like we're going to be done by about sprint 17. Now, the cone of uncertainty, which is the traditional level of estimation accuracy or inaccuracy, if you prefer, within a typical points-based or relative sizing estimation technique, is plus or minus 30%. I did say we were running at plus or minus 5%, but we still use the cone of uncertainty, which is a well-known measure for us to determine where we think we could deliver. We might be able to deliver as early as sprint 13 in this example. We may be as long as sprint 21. So if you're doing 2-week sprints, somewhere between 26 and 42 weeks. But hopefully we'll be done by about sprint 17 in about 34 weeks' time. Of course, not everything always goes according to plan, no matter how accurate or how great our estimating techniques are. And in this example of a simple release burn down chart, you can see we've got some chunks of work happening, but based upon our new trend, we have no idea when we're going to be done. Conversely, in this example, we can see that we're trending to deliver early. The team have increased their velocity and things are going well for us. The wind's in the right direction, and all being well will be done by sprint 12. So you can see you can start to create a traditional release plan. It keeps the project managers happy and the middle management senior executives happy. We've got 3 key deliverables here. We've sized them all, 300 some points, 72 points, 192 points. We're able to plot those on a traditional milestone chart, and using our velocity and our sizing, we can now say we think we can deliver this big idea of number 1 around about sprint 6 or 7, big idea or feature number 2 around sprint 8, and finally the last big feature for this particular release should be around sprint 12 based upon our current velocity trend. Of course, the most important thing is you must adjust this
every sprint. You must be looking at the velocity the team is delivering each sprint, or the average velocity over the last 3 sprints, something called yesterday's weather. And then we need to be adjusting our trend based upon that velocity. And another factor you need to take into account is that we may be adding additional backlog. We may have emerging requirements. We may be learning new things, which means the size of the backlog will increase. But we also may be removing some requirements. In conversation with our customer at sprint review, we're discovering that certain things aren't important now. So the backlog is continuously evolving within this release or within this period of work that we're focused on. So the size of the backlog may increase or decrease. The team's velocity may increase or decrease. So we have to continuously adjust this forecast based on those 2 metrics. So now if we're able to calculate with some reasonable accuracy the size of our initiative, and we're able to calculate from that the size of an epic or feature or whatever you want to call a big piece of work, and we know the velocity of the team, we now know the number of sprints that it's going to take to deliver that. If we know the number of sprints and we know the cost of the team per sprint, which is relatively easy to calculate, we now know the cost of an epic. So now you can say to the accounting team, hey, this thing's going to cost us 12 sprints, and every sprint costs us $10,000. So therefore, the cost of this piece of work, this feature, function, capability, this epic, is $120,000. So the next time somebody says, hey, we need to add this to the team's backlog, we need to add this to the product we're delivering, you can now use this technique to rapidly determine a price and ask them, do you really want to add this? Is this the right value for you, the right return on investment? Is it right for us now to prioritize this piece of work? Typically when we were doing this at Toyota, it would take us about 2 hours to come up with a reasonably accurate, that sort of 90% proven accuracy estimate for a year-long initiative. And we would continuously monitor this every single sprint. Teams were doing 1 and 2 week sprints, so that was able to be monitored very, very rapidly. And then we could have conversations when customers and leadership came and said, hey, we want to add this new feature, function, capability in. This has now become important. We're able within sometimes 10-15 minutes to be able to calculate the size of that additional piece of work, because we had lots of baseline data which allowed us to be able to do that rapidly with the team who are well skilled and well versed and used to this piece of work. And then of course we could add that, do the math and quickly calculate what that extra capability was going to cost, and then ask whether or not it should be prioritized and should be added to the backlog. And there was some simple yes or no decisions based upon that. So that was Large Effort Estimation by Dave Slayton and Nigel Thurlow. I hope you found it useful. I hope you found it valuable, and I highly recommend you try it and test it for yourselves. Thank you.